It's January 2026. And if you've been looking around at the world of science and technology lately, you can feel it.
Oh, you can definitely feel it.
The temperature is it's rising. We are standing at the exact intersection of these two massive forces, artificial intelligence and biology. And the tension, it is just palpable.
It really is. It feels like we're oscillating between, miracles and nightmares almost on a weekly basis.
Yes, exactly.
One day you'll read about a breakthrough in curing some rare genetic disease we all thought was untouchable. And then the very next day, there's a warning that the exact same algorithm could help create a new pathogen. It's a lot to process.
It's overwhelming. And that is exactly why we're doing this deep dive today as part of the Connected Ideas Project. We want to try and cut through that noise.
We have to.
We aren't here to, review the latest gadgets or just fear-monger about sci-fi stuff. We want to map the intellectual landscape of this specific moment. Because beneath all the headlines, there is this profound philosophical struggle happening right now.
That's the right word for it, a struggle. And what's so fascinating and frankly concerning is that the core of this problem isn't really the technology itself.
Yeah.
The hardware is doing what we designed it to do. The problem is a phenomenon that some people are starting to call a collapse of proportionality.
Collapse of proportionality. I actually bookmarked that phrase when I was prepping. It sounds heavy, almost academic. But the more I thought about it, the more accurate it felt.
It is.
But before we really unpack that, we need to set the scene. This isn't just happening on social media or in some abstract papers. This is influencing decisions in boardrooms and government labs right now, isn't it? It is happening today. To understand the stakes, you have to imagine a meeting room. Could be in Washington, could be Geneva, could just be a Zoom call. But the conversation, it's split into two violently opposing camps.
And they're just shouting past each other.
Completely. And that's the tragedy. They've created this dangerous void right in the middle, which is ironically where the actual solution is. Okay, so let's identify the factions. Who is sitting at this table?
Well, on one side, you have the group we might call the accelerationists.
I think we know this archetype.
Yeah.
The techno-optimists, right? The only way out is through crowd. Move fast, build the future.
It's deeper than just optimism, though. It's a moral imperative. It's driven by urgency. When this group looks at AI-enabled biology, they aren't seeing stock prices or academic papers. They measure their timelines in patience.
Patience, not papers.
Exactly. They are thinking about the millions of people suffering from rare diseases that, big pharma has historically ignored because the market's too small. They're looking at cancers with no second-line therapies.
Meaning if the first drug fails, that's it. You go home.
You go home to die. It's a heavy reality to sit with.
It is.
So to an accelerationist, AI-enabled biology is applied mercy. Their argument is that we finally have a tool that can decode the complexity of human biology at scale. So for them, every month of delay, every pause for safety checks, that translates directly into a body count.
That's a compelling ethical stance. I mean, if I have a tool that can save my child, and you tell me I can't use it because of some hypothetical risk, I'm going to be furious.
Of course. It's very hard to argue against the morality of saving lives. But then you look across the table.
Right.
On the other side, you have the catastrophists. Now, they usually reject that label.
I bet they do.
Yeah, they prefer safetyists or risk-aware, but they are focused entirely on the downside. They don't speak in terms of patience.
So what's their language?
They speak in terms of failure modes, containment, and irreversibility. And they anchor their whole argument on a fundamental truth that the tech world often ignores.
Which is?
Biology is not software.
I think this is where the Silicon Valley mindset just hits a brick wall, right? In software, the motto for a decade was move fast and break things.
Right.
If you break an app, you push a patch on Monday morning, no big deal.
Exactly. If you push a bad update to a banking app, you lose money. You can fix it. But you cannot roll back a biological release.
There's no undo button.
None. If a model helps design a viral vector that's more transmissible than intended, and that gets out of a lab, whether by accident or on purpose, you cannot attach an ecosystem.
So their fear isn't just that the AI will make a mistake, but that the mistake will be self-replicating?
That is the crux of it. They worry about model-enabled pathogen design or even just the democratization of these capabilities. If you have a foundation model that can design biological agents and that leaks onto the open internet,
suddenly you don't need a PhD in a multi-million-dollar lab to cause harm.
the capability just completely outruns the containment.
So we have an immovable object and an unstoppable force. One side is screaming, we have to hurry, people are dying, and the other is screaming, if we hurry, everyone might die.
And here's the uncomfortable truth. They are both right.
Great.
Both sides come to this meeting armed with data. Both claim the moral high ground. But because they're dealing in these absolutes, the conversation it hits a wall. And that deadlock is what creates the collapse of proportionality.
Okay, let's dig into this concept, a collapse of proportionality. It sounds like a diplomatic way of saying everyone is losing their minds. What does it actually mean in practice?
It refers to a flattening of reality. Because the debate is so polarized, we've lost the ability to distinguish between different types of risks. The whole discourse just compresses everything into one giant existential nightmare.
Give me an example of this flattening. How does it show up?
Okay, think about how we discuss these AI tools in biology. In the current climate, a model designed to optimize an enzyme for, say, laundry detergent.
Wait, hold on. Laundry detergent. Are people really conflating laundry enzymes with bioweapons?
Rhetorically, they are, and here's why. The underlying technology generative AI for protein design is largely the same.
Oh, okay.
So a foundation model used to prioritize drug targets, which is basically a super smart search engine for medicine, is treated as rhetorically adjacent to a model capable of designing novel toxins.
I see. So because the engine under the hood is similar, the output is treated with the same level of suspicion. The nuance between helping a scientist find a cure and an AI building a virus from scratch just gets lost.
It gets completely erased.
Right.
The distinction between assisted discovery, where AI is helping a human and autonomous synthesis, where the AI does the whole thing, it just disappears.
Yeah.
In this collapsed context, everything becomes potentially catastrophic.
And when you view everything as an existential threat, your demands for safety become impossible to satisfy.
Impossible, exactly. Because if every tool is a potential weapon of mass destruction, then the public and the regulators, they start to demand zero misuse.
Perfect foresight.
They want to guarantee that nothing will ever go wrong, which, if you know anything about science,
It's ridiculous. You can't guarantee zero risk when you get out of bed in the morning.
it is antithetical to how science works. I mean, think about the actual biologists in that room listening to policymakers demand absolute safety. They know that biology is messy, it's probabilistic.
Right. Experiments fail constantly. Drugs that look perfect in a simulation fail in mice. Drugs that work in mice fail in humans.
That is the reality of the field. Progress in science is all about managing uncertainty, not eliminating it. But in a proportionality collapse, probability is viewed as negligence.
So if you can't guarantee 100% safety, the catastrophists say you shouldn't build a tool at all.
That's the argument.
Which leads us to the policy side of this. If the demand is absolute safety, the only logical response is stop. Do we see people calling for a full pause?
Constantly. You hear calls to pause AI and biology until governance can catch up.
Which sounds reasonable on a bumper sticker. Let's wait for the rules. Why shouldn't we do that?
It's a trap, really, for two reasons. First, what does caught up even mean? The tech moves faster than legislation ever could. But more importantly, these broad calls for pause are scoped to fear, not to capability.
It's regulation by anxiety.
Perfect phrase for it. And like most prohibitions, it doesn't actually stop the behavior, does it? That's the critical insight. When you try to ban or pause a technology this accessible and this valuable, the work doesn't stop. It fragments.
Break that down for me. What does fragmentation look like in this industry?
Well, look at the big players first. The major pharma companies, big tech labs, they have huge legal teams. If you slap a vague moratorium on them, they'll comply on paper. They'll go quiet.
And keep working behind closed doors.
Exactly. They'll wrap it in trade secrets to avoid scrutiny, so you lose transparency immediately.
Okay, so the big guys go into stealth mode. That's bad for public trust. What about the rest? The little guys.
The startups, the university labs, they get crushed. They just don't have the resources to navigate vague regulations, so they stop innovating. But the most dangerous shift happens at the margins.
You mean the bad actors?
Not even bad actors, necessarily, just impatient ones. If you make legitimate research too difficult in the US or Europe, the work just moves.
It goes offshore.
It goes to jurisdictions with weaker oversight. Or it moves into this gray zone of open science where people stop sharing their data because they're afraid of being labeled as reckless.
That seems like the ultimate irony. By trying to enforce perfect safety with a pause, you actually drive the research into places where you can't see it at all.
That is the illusion of safety. We feel better because we banned it, but we have actually increased the unmanaged risk. We fracture the very community, the open science community, that we need to detect these threats in the first place.
So we're creating a blind spot exactly where we need eyes on the problem.
Precisely.
This is painting a pretty grim picture. We have two sides screaming absolutes, a middle ground that's just evaporating, and innovation fleeing to the shadows. But surely there has to be a third option, right?
There has to be.
If we don't pause, but we also don't want to run blind into a catastrophe, what do?
We have to rebuild the middle. And the only way to do that is to stop shouting answers and start asking better questions.
Better questions. Okay, give me an example.
Instead of asking the binary question, is AI in biology dangerous? Which is useless because the answer is always yes, potentially. We need to ask, which applications are dangerous, under what conditions, and with what controls?
So we need to get specific.
Ruthlessly specific. We need to move from the precautionary principle, which, let's be honest, often means doing nothing, to proportionate governance.
Okay, let's apply this. How do we differentiate the risks? Because to a layman, a protein folding model sounds the same no matter what it's doing.
We need a sliding scale based on capability and reversibility. Let's look at 3 comparisons. First, intent. A model that helps identify a target for CRISPR to treat sickle cell anemia is fundamentally different from a model capable of end-to-end pathogen design.
Right. One is a flashlight helping you find a key. The other is a blueprint for a weapon.
Correct. They should not be governed by the same rules. Second comparison. Context. A tool used inside a regulated pharma pipeline with toxicity screenings, animal trials, FDA oversight is not the same risk as that same tool released open source with no guardrails.
That seems obvious, but I guess in the current debate, the fear of the open release dictates the rules for the closed lab.
Exactly. We're regulating the pharma lab as if it's some chaotic internet forum.
Yeah.
And the third, and maybe most crucial distinction, is in silico versus in vivo.
In the computer versus in the body.
Right. A reversible error in a computer simulation is just data. You delete the file. An irreversible release in a living organism is a biological event. The governance needs to be heaviest at the point of physical manifestation.
So you can simulate whatever you want, but the moment you order the DNA synthesis, the moment it becomes real matter, that's the choke point.
That is where the friction should be. We need to invest in institutional capacity biosafety checks, screening for DNA synthesis providers, auditability. We need to build the infrastructure to check the work rather than just try to ban the math.
That sounds like actual work. It's not just passing a law saying don't do bad things. It's building a system to catch the bad things.
It is. It requires treating this like a mature industry like aviation or nuclear energy, not like some magic trick. We don't ban planes because they could crash. We build air traffic control.
Right.
We need the biological equivalent of air traffic control.
So let's try to summarize where we are. We're stuck in this trap. On one side, you have the move fast crowd, whose philosophy works for code, but is frankly terrifying when applied to viruses.
Absolutely.
On the other side, we have the stop everything crowd, who are creating a false sense of safety while actually driving the real risks underground.
Right. And the safe path, the only real path forward, is a disciplined, nuanced middle. It is boring compared to the extremes. It requires work. It requires distinguishing between a laundry enzyme and a toxin. But it is the only way we get the benefits without the catastrophe.
And we really need those benefits. I keep going back to that phrase you used earlier, applied mercy.
And that's the hardest truth in the room, and it's one we have to sit with.
Yeah.
Not acting also carries risk.
We usually think of risk as doing something. If I drive the car, I might crash. But you're saying inaction is a choice.
It's a choice with a cost. Lives not saved are a risk. Diseases not treated are a risk. Pandemics not predicted early enough because we were too scared to build the detection tools. Those are failures, too.
That puts a whole new weight on that pause button.
Yeah.
Pressing pause isn't a neutral act.
No, the AI and biology debate doesn't need less concern. It needs better judgment. It needs us to acknowledge that trade-offs exist and to navigate them with open eyes.
You know, this whole discussion reminds me of something essential about where we are as a species right now. We're building tools that are rewriting the rules of life itself. It feels like we're running an experiment on ourselves.
Right, are.
Yeah.
And I think the most provocative thought to leave with is this. At the frontier of technology, humanity is the experiment.
Humanity is the experiment. That's haunting.
The technology isn't the experiment. AI isn't the experiment. We are. The experiment is whether we have the collective wisdom to use these tools. It's not about whether the tech can do it. It's about whether we can govern it.
That shifts the responsibility right back onto us. not the algorithms, but us. It's a sobering thought, but an empowering one, too.
As it should be.
Well, that is the perfect place to leave it for this deep dive. It's a complex topic, but hopefully we've helped you see past the shouting matches and into that vital missing middle ground. Thank you for joining us on this installment of the Connected Ideas Project. Keep asking better questions, and we'll see you on the next deep dive.